Welcome to Ask and Learn.
Here we have a beam that is cantilevered on a slider over at the left end. So we have a moment acting, so it can't. The angle here is constrained to be 0, but we can slide vertically, so there's no vertical force component acting there. There could be a horizontal one, but again, that's just 0 because there's no other horizontal loads acting. We have a load here, and then we have a roller support over on the other end. So if we F1 is our load, and it's from the origin, which I'm using this point as the origin, it's L over 2 units to the right. F2 is here, and it's L units to the right. And then we have a point moment acting. And we don't really care where it's acting. A moment could be acting anywhere, in a rigid body situation anyway. And that has a magnitude, and again I've drawn it positive, of m, and that is in the out of plane direction. So in this case, we have two forces, so we need to sum those forces and set both their components equal to 0. And again, we'll find trivially that n equals 0, and so we'll get a force that equation that relates P and V. And then we also know that the moments from P and V must be equal to the moment, or plus this moment here, must be equal to 0. And I've just labeled this 3. So this will give us an equation, and this will give us another equation, since only one of the 3 components in each is not trivially satisfied. And so what you find is V equals P, as we'd expect, and then M equals minus LP over 2. And we can see that basically we drew it in the wrong direction, so it's actually in this direction. And that's the magnitude there. And it's a little hard to see why it's in this direction, but basically because there's no support here, this wants to slide down and it can't, and so you need a moment there to counteract that from happening.